Today we're going to be sketching polynomials by hand and solving inequalities. So we're going to sketch polynomials without using a graphing calculator. And the way we're going to do that is first determine the zeros of the function. Then we're going to determine the end behavior of the function, and then we're going to fill in the rest of the graph. So if we look at this example, we can tell what the zeros are going to be. So if we solve x minus 2, if we set that to 0, we get 2. If we set this one to 0, we get negative 1. If we set this one to 0, we get negative 4. So we have our three x-intercepts. So if I go to do a quick sketch of this, I know at negative 4, negative 1, and 2 that there's an x-intercept. Okay. For these, I just also want to find the end behavior. So if I multiply these together, which I'm not going to do, but if we multiplied them, because there's three x's, this would be an x cubed function. And the a value would be a positive, because I have a positive x, and a positive x. Since it's x cubed, and my degree is odd, and it's positive, I know that my ends are going to look like this. They go in opposite directions, and they end positive. So when I fill this graph in, this is going to start here, it's going to end here, and then we can fill in the rest of the shape. So we don't need the turning points here. We're not trying to be very specific. We're just trying to do a quick sketch of this. All right, so let's look at another one. So this one, if I set this to 0, I get 0. If I set this to 0, I get 5. If I set this to 0, I get negative 2. So we're going to sketch this real quick. It crosses at 0, at 5, and at negative 2. Now again, there's three x's. So if I multiply this, I'd have x cubed. Because I have a negative 1 x and then two other regular x's, I'm going to have a negative x cubed function. When it's negative, remember we start positive and we end negative. So I'm going to start positive, I'm going to end negative. And then you're just going to fill in the shape. So this is going to go down, up, and down. Okay, let's look at another one. Okay, so again, x is 0 from this factor. X equals 2 from this factor. X equals negative 3 from this factor. And x equals 2 from this factor. So I have 2 of the same, which means I have a multiplicity. So I have 2 of multiplicity 2. I have 0, and I have negative 3. When I FOIL this together, if I were to FOIL it, I have 1, 2, 3, 4 x's. So I'm going to have x to the 4th. And because one of them is a negative, it's going to be a negative. When I have a negative x to the 4th, both ends are going to point down. So this end is going to point down, and this end is going to point down. So when I follow the shape, this is going to go up and down. And then I have a multiplicity at 2. So it's going to go up and come back down. Okay, so we're kind of putting together all the things that we know. We know what the x-intercepts are going to be. We know how a multiplicity behaves on the graph, what it looks like, that it looks like a quadratic. And then we know the end behavior, so we're putting everything together. All right, so let's look at this one now. Okay, so again, we're going to set this to 0, so we get 2. We're going to get negative 4. We're going to get negative 2. And then we're going to get positive 4. So when we go to graph this one, 34, 1, 2, 4. So I have positive 2, I have negative 4, I have negative 2, and I have positive 4. Okay, there's 4 x's, so I have x to the 4th. All of the coefficients of the x's are positive, so both ends are going to point up. So this end points up, this end points up, and then I follow the shape. And there's my sketch. Okay, so here we're going to just try some again without the calculator. Okay, so same idea. Here, we set them to 0. We have -2. We have 3. We have -1. And we have 1. So we're going to sketch it. -2, -1, 1, and 3. Okay, again, there's 4 x's, so this would be an x to the 4th. And since all of my x's are positive, I know my ends are going to be both pointing up. So up, and I'm going to follow the shape. So where you draw this, it doesn't matter. If you want to be very specific, we can find the y-intercept by multiplying our numbers together that are the constants. So 2 times -3 would be -6, times 1 is -6, times -1 is 6. So if we want to be very specific, we can make this y-intercept at 0, 6. But you don't need to. You don't know where the max and the mins are from these because we're not using a calculator. So somebody could draw it completely different than you as long as the x's are the same. So we could redraw this, let's say. Somebody might draw it like this. Okay? As long as the x-intercepts and the y-intercept, or at least just the x-intercepts and the end behavior are the same, it doesn't matter, okay, for these purposes. All right, for the next question, it's not factored for us. So all the ones we've done so far have been factored for us. So we have to factor this. It's treat like a quadratic, so multiplies to 9 and adds to -10. So I can use my shortcut, and I'm going to have -9 and -1, and I set it to 0. Each of these can be broken down further with difference of squares. So x plus 3, x minus 3, x plus 1, x minus 1. And we're going to set each one to 0. So we get -3, we get +3, we get -1, and we get +1. So when we go to sketch this, and we know that it's an x to the 4th function, okay, and that egg is positive, so my ends are going to both be up. And then I'm just going to follow the shape. Okay, so solving inequalities, we're going to do the same thing. We're going to do a quick sketch, and then once we do our sketch, we're going to look to see what part of the graph is above 0 and what part of the graph is below 0, depending on the inequality symbol. So if we look at this example, if I set this to 0, I'm going to get -1. Here I'm going to get 3. And here I'm going to get 5. So I'm going to do my sketch and I have -1, 3, and 5. I have x to the 3rd since there's 3 x's. So my ends are going to be down to up since I end positive. I'm just going to follow the shape. So I want to know where is g of x, which is our function, where is it greater than 0? So where is y greater than 0? So if we look at this piece, these are all have positive y's. Okay, same thing goes for this. So what I just highlighted in green, those all have positive y values. So it's where it's above the x-axis. Okay, and where is it less than 0? So I'm going to do this in purple. Okay, so what's highlighted in purple is below the x-axis, and that's where it's less than 0. So when we're writing these, okay, we can write them as intervals and also graph it on a number line. So for this one, we're going to graph on a number line. So where it's greater than 0, so that's the green, and it's greater than 0 at -1, okay, up to 3. So from -1 to 3, it's above the x-axis, and then also 5 and greater, so 5 to infinity, so that goes that way. Where it's less than 0, that's up to -1. So from -infinity up to -1, and then from 3 to 5 in there. So what would change if the question was g of x is less than or equal to 0? Well, if it's less than or equal to, we're going to have a filled-in circle. So at -1, we're going to have a filled-in circle instead of an open circle. So if it doesn't include it, it's open. If it does include it, if it's the line underneath, we're going to have a closed-in circle. Okay, so again, 3 and 5 then are both going to be closed circles, and we're going to have the space between them. Okay, so we write our intervals kind of like our intervals of increasing and decreasing. We write them with parentheses or square brackets, depending if it includes it or not. So the first example here, it's an open interval. So since 0 and 4 have parentheses, they have open circles because they don't include 0 or 4. This one, since it's closed at 4, you have a square bracket at 4 and a parenthesis at 0 since it doesn't include it. And the next one, square at 0 because it includes it, regular parenthesis at 4. If it includes both, you're both squared. All of your infinities, so if it goes to the left or to the right, it's infinities or negative infinity. It's going to, this should be a positive infinity. Those infinities are always going to be in the parentheses, since it can't include infinity, since it's not an actual number. Alright, so if we look at this, first thing we want to do is factor it. So we're going to take out the x. We're left with x squared minus x minus 42. I'm going to factor this, so -7 and +6. Okay, so if I solve these, I have 0 as an x-intercept, I have 7 as an x-intercept, and I have -6 as an x-intercept. So we're going to do a quick sketch. So 0, -6, and 7. I have x cubed, and it's positive. So I'm going to start negative and positive. Follow my shape. So I care about where it's greater than or equal to 0. So where is it above the x-axis? Well, it's above the x-axis here. Oops. And here. So first let's write our intervals as parentheses. So from -6 to 0, and it includes it since we have the included line underneath. So we're going to have a square bracket from -6 to 0, and it includes 0 as well. And then also including from 7, and it goes to infinity because it's to the right, and that's going to be a parenthesis since it can't include infinity. On our number line, -6, 0, and 7. So it's going to be a closed circle at -6, closed circle at 0, what's in between them, and then a closed circle at 7 to the right. Okay, so let's try one of these. So to solve them, we get 3, we get -1, and we get 2. So we're going to do a quick sketch. So we have -1, 2, and 3. Okay, if we multiplied it, we have x to the third, which is positive, so it's going to be down and then up. Okay, follow the shape. We want it to be less than 0, so we're going to look here and here. Okay, so it's going to be from negative infinity, which is in a parenthesis, since we can't include negative infinity, to -1. And it doesn't include it because we don't have the included line, so parenthesis. And then also from 2 to 3, both in the parenthesis. And then on our number line, -1, 2, and 3. Open circle at -1 goes to the left. Open circle at 2 and 3. Okay, what's in between them?